AP Calculus ABBC Exam Review Differential Calculus Fundamentals Question 5 Comparing Features of Functions. In this question, we'll examine comparisons between y-intercepts, evenness, minimums, that's like minimum values, and periodicity, whether or not the function repeats over a certain interval. F is a function defined on non-negative integers. And in case you're unfamiliar with the term integer, integers are whole numbers such as 0, all the counting numbers 1, 2, and 3, as well as negative numbers like -7 or even -11. But here we're told that the function is defined on non-negative integers, so it's defined on all values greater than or equal to 0. A verbal definition of f is given below. So this is the definition of f. If the remainder of x is divided by 3, actually, if the remainder of x divided by 3 is 0, then f of x is equivalent to 11. The second defining parameter is that if the remainder of x divided by 3 is 1, then f of x is equal to -7. And also, if the remainder of x divided by 3 is 2, then f of x equals 2. Okay, so these are 3 defining parameters that we're told about the function f. On all real numbers. And real numbers are basically every numbers. This includes decimals, whole counting numbers, fractions. The only thing that real numbers don't include is the term I, which is defined as the square root of -1. So this is imaginary, it's not real. All other numbers such as 11.3, 67, -67, numbers large and small, these are all real numbers. So its graph in the range between -10 and 10, that is -10 is less than or equal to x, x is less than or equal to 10, is given below. So this is shown here. Okay. Suppose the trend suggested at the graph's edges continues. So here we see that there is some type of periodicity in this particular function. It repeats over an interval of about 4 units along the x-axis. All right. So which features are shared by f of x and g of x? Select all answers that apply. Is it that they have the same y-intercept? Are they both even functions? Do they have the same minimum values? Or are they both periodic? The first thing that we're going to determine is whether or not these two functions have the same y-intercept. So let's determine whether or not functions f and g have the same y-intercept. The y-intercept is where the function crosses the y-axis, okay? So this axis right here, usually the vertical. And this occurs when x is equal to 0. So f of 0, based on the parameters that are described to us in these defining terms, equals 11. Because we see here the remainder of x divided by 3 is 0. That's just another way of saying f of 0 equals 11. Okay, now let's look at function g to determine if it has the same y-intercept as function f. So again, the y-intercept occurs when x is set equal to 0, and g of 0 yields this value right here, which also happens to be 11. Therefore, if g of 0 is 11, that's g of 0 equals 11. The functions f and g have the same y-intercept. So this is a correct answer choice. So I'm going to demonstrate this by choosing 4 and -4. So g of -4 yields 11. Therefore, g of 4 should also yield 11, and we see that it does. And another way to ascertain that this function is in fact even without doing any math is to just do a simple visual inspection and to notice that it's symmetrical about the y-axis, okay? So we see that if we reflect or were to fold this graph in half and overlap, you would have a symmetry, and therefore this function is symmetrical over the y-axis. Therefore, it's even because of this fact also. When determining whether or not f is an even function, don't be intimidated just because f is described to you in terms of 3 defining stipulations. Because we can determine whether or not it's even from the introductory information that we're given. So here we see, or we're told rather, that f is not defined on non-negative values. Well, f is only defined on non-negative values. Therefore, it isn't defined on negative values. And if a function is not defined on negative values, it cannot fit the definition of an even function. So it's simple as that. G is even, f isn't. Therefore, evenness can be eliminated as an answer option. All right, So because the function f is defined by these four parameters, 1, non-negative integers, the remainder 0 stipulation, the remainder 1 stipulation, and the remainder 2 stipulation, we can use this information to determine where the minimum f of x occurs. And so after reading, we see that these are all our f of x values. And the lowest value is going to be -7. This is more of a thinking man's game rather than neat mathematics. So once again, you might feel uncomfortable making that determination of a minimum just based off of a definition of a function, but this is the strategy you would take in the event that you encounter a question like this. So the minimum of f of x is -7. Now let's determine the minimum of g of x to see if both functions have the same minimum. In determining the minimum of the function g, we can just simply do a visual inspection. And a visual inspection of g reveals that the lowest value of g of x occurs at 0. And since the minimum of g of x is 0 and the minimum of f of x is -7, these two functions do not have the same minimum value. Therefore, we can eliminate this answer option. Now let's determine whether or not f displays periodicity. So this might seem a little strange to you because we're just given 3 stipulations to define f, but those 3 stipulations are what establishes its periodicity. So we're told that if the remainder when divided by 3 is 0, f of x equals 11. When the remainder is 1, f of x is equivalent to -7. And when the remainder is 2, f of x is equivalent to 2. So we know that every 3 numbers will fit one of these criteria. Let's say x were 0, then 0 divided by 3 equals 0, therefore f of x is 11. Let's say x is equivalent to 1, then 1 divided by 3, well, that would give you some interval value between -7 and 11, therefore it would fall somewhere between this range. Well, let's say that x were 4. Okay, then you would get -7. And let's say that x were 5, you would get 2. A remainder of 2, therefore f of x would be 2. And every other value in between would give you some f of x that ranges between either 2 to -7 or 2 and 11. Okay, so there is a periodicity over a range of 3. Therefore, we could say something like f of x plus 3 equals f of x. So f of x repeats over a period of 3. And I know this seems very uncomfortable right now, but there'll be many more questions with this type of criteria. So just do another one and you'll feel more comfortable answering a question like this. All right, so we just established that the function f is in fact periodic. So now let's determine whether or not g is a periodic function, and it's obviously a periodic function, but let's be a little bit more specific about its periodicity. So we see that the function starts at 0 at a maximum of 11, goes all the way down to a minimum of 0, and then increases back to 11. So this is a period. The time or the interval it takes to return back to its original value, and we see that occurs over a range of 4 units. Therefore, g of x equals g of x plus 4 Therefore, we can establish that the period for the function g is 4, and both functions are periodic, both f and g. Okay, so finally we can say that the functions f and g are both periodic functions, so option D, that have a y-intercept of 11. So option A. All right, so the correct answer choices are the first option and the last option. They have the same y-intercept, and they are also both periodic functions.